Hi, welcome to Lab 10, which is the final project and summary. This is just a recap of Module 1, Geospatial Machine Learning with Python. So for those who have been following this series tutorials, we started with Lab 1 and then finished with Lab 9. So the main components of this series was mainly on machine learning with Python, where we started with labs 1 and 2, looking at some of the Python fundamentals that we need to look at when we are running machine learning. And then we also looked at different machine learning methods, such as k-nearest neighbor, support vector machines, decision trees, and random forest. And then we moved on to concrete examples of applying machine learning methods for land cover classification and estimating above ground biomass. So some of these key components that we looked at was that, for example, the problem definition, the data sources. We did a bit of exploratory data analysis and feature engineering. And we also looked at the machine learning model selection, particularly for classification integration. And then we looked at the model training, validation and testing, as well as the visualization of the model outputs. So this is a recap of some of the key concepts and tools that we used. So first we started looking at supervised learning, with particular focus on classification and regression. And then we looked at geospatial data processing pipelines, for example, data cleaning and band selection. And for the machine learning models, we mostly focused on k-nearest neighbor, the decision trees, random forest, and support vector machines. And we also did a bit of explainable machine learning, both for classification and regression. Right, some of the challenges that we encountered along the way, for example, is the issue of the data quality, and also issue of the imbalanced data for land cover classification. And of course, we also have challenges of overfitting and underfitting. And then also of importance is the lack of reproducibility of some of the machine learning workflows. As we said, it's quite difficult to apply one machine learning model used in one place to another, although we attempted to do this for areas that have got similar geographic characteristics. And the other things that we did not look into, for example, the focus or the concept of spatial dependencies that we did not really take into consideration. This is something that we will look forward to work on in the near future. And we also found that even if we are using some of the explainable machine learning methods, still we still have a difficulty in understanding the black box models, such as the random forest and support vector machines. So, however, we have a lot of opportunities to work on. For example, to explore more on spatial transferability. That is looking at the models that can generalize across geographic regions. So this is very useful, especially in areas where we don't have enough training data sets. And also try to focus on improving the explainable machine learning, so that the so that we focus on the spatial components. So remember, most of the methods that we are using, they are just borrowed from machine learning or computer science. They are not really from the geospatial sciences. So there is a need to work on that. And then also another opportunity is to scale these machine learning models, especially for regional or maybe global mapping, and try to use more to use other cloud platforms so that we can scale the machine learning geoprocessing workflows. And then finally, focus more on using most of these developed geospatial aware machine learning tools, for example, TouchGeo. Right, so the next steps is for those who are interested, they can continue experimenting with machine learning and explainable machine learning models for land cover classification and above ground biomass estimation. So I've prepared these collab notebooks. You can access these notebooks. I'm going to leave the links in the description so that you can continue working on your own and testing various machine learning models for your project of interest. Right, so the next lecture is going to be on geospatial deep learning with Python. So I'm going to start this series. So please, for those who are interested, you can follow along. Right, and I'm also going to, I'm currently preparing a seminar and a workshop that I plan to do in mid-May. So the date is not yet fixed, but I'll be informing you as we continue with our lecture series on geospatial deep learning with Python. So thank you very much for watching this short tutorial. See you in the next series on geospatial deep learning with Python.